Let's solve 2023 first problem of USAJMO, USA Junior Mathematical Olympiad. After this problem, I will write a homework for you similar to this and useful for factorizing a term. Okay, let's start. There's many factorizing, famous factorizing that is important to work on, especially when x, y, z are integers. If you want to learn them, you can send message to my WhatsApp number in the description and comments. Okay, let's start. Find all triples of positive integers x, y, z that satisfy the equation. 2 times x plus y plus z plus 2xyz whole squared equal to 2xy plus 2yz plus 2zx plus 1 whole squared plus 2023. We have sum of 4 terms whole squared, so first you should know this. I write it for 4 terms. Also, if you have 3 terms, 2 terms, n terms, the idea is same. You write it twice. A plus b plus c plus d, a plus b plus c plus d. Then you say, okay, a squared we have b squared, we have c squared, we have d squared. And then we have a, then we have 2ab, ac, 2ac, add, 2ad, plus 2bc, 2bd plus 2cd. Okay, now let's focus on our main equation. I write it as 2 times the left hand side. If you use this, it will be first one squared x squared, next one squared y squared, next one squared z squared plus this one squared. It will be 4x squared y squared z squared plus 2 times like here. 2 times xy, 2xy, let's focus on this part first. 2xy plus 2xz plus 2yz. We've considered this thing now. 2x times this, 2 times x times 2xyz will be 4x squared yz plus 4x y squared z plus 4x yz squared. Okay, equal to this one whole squared will be 4x squared y squared plus 4 each term squared, like here a squared, b squared, c squared, 4y squared, z squared, plus 4z squared, x squared, plus 1, now plus 2 times this, let's consider these 3 terms first. 2 times 2xy times 2yz will be 8xy squared z, 8xy squared z. 2 times this, 8x squared yz. 2 times this, 8xyz squared. Then plus 2 times this, 4xy. This times this, 2 times that, 4yz. 2 times 4xy, 4yz, 4zx. One term is left plus 2023. So let me minimize it. Okay, to have more space. It's okay. Plus 2023. Now, let's cancel the common terms. So, 2 times 2xy is 4xy, and here we have 4xy. 2 times 2xz, we have 4xz, here 4zx. 2 times 2yz, 4yz, 4yz. We've cancelled 2 times 4x squared yz, 8x squared yz. We cancel x squared yz with this. 2 times this is 8xy squared z, 8xy squared z. Here 8xyz squared, 8xyz squared. And then let's consider another common terms. Here we have 2x squared plus 2y squared plus 2z squared plus 2 times 8. 2 times 4, 8. 8x squared y squared z squared equal to 4x squared y squared plus 4y squared z squared plus 4z squared x squared and plus 1 plus 2023. So it will be plus 2024. Okay. Now in next term, as you can see, always we have 2x squared, 2y squared, 2z squared. Also, you can write it as 2x squared times 2y squared times 2z squared. I can write this one as 2x squared, 2y squared. So I use changing variable. Look, the solution is from here, okay? So I want to use A, B, C, D again. It's okay, because it's as a lemma, it was identity I wanted to explain for you. Because it's not good to use repeated variables. So I say I consider A equal to 2x squared, B equal to 2y squared, C equal to 2z squared. So if I write this one, it will be A, the next one B, the next one C, this one ABC, this one 2x squared, 2y squared, AB, this one plus BC, this one plus AC, plus 2024. Okay. Now here we can see that, for example, try to find at least one example for you. One way is to factorizing. You can say that, okay, if for example A is 1, then left side is BC plus B plus C. Right side is what? Is BC plus A plus B plus C. So if A is 1, this one equal to this one. Okay. So these fours are equal. Now we try to factorize. Okay, so I take all things to left hand side. So it will be A plus B plus C minus AB minus BC minus AC, something like Vieta's formula, plus ABC equal to 2024. So it is like Vieta's formula, for example, when we have x minus A, x minus B, x minus C, then you say, okay, for example, it is x cubed plus, for example, x squared, it will be minus a minus b minus c. Then plus x, it will be ab plus ac plus bc. Then you say in next term, it will be minus abc. Okay, and it's similar to this. And if you consider 1 here, it will be what? 1 plus negative a, negative b, negative c, plus ab plus ac plus bc, minus abc, if x is 1. And as you can see here, the signs are different. So we should multiply by 1. So I said if x is 1, this factorizing, it will be what? You can write a minus, I want to multiply by negative 1, a minus 1, b minus 1, c minus 1, equal to negative 1 plus a plus b plus c minus ab minus ac minus bc plus abc. Okay, so this term is what? This term is this. Okay. So it will be what? It will be this term. You take negative 1 to left hand side plus 1. So I've concluded that this term, let's consider, for example, it is t. T, t. T is what? A minus 1 times b minus 1 times c minus 1. If you take this here, plus 1. So if I write it, let me move this part. So you say, okay, it is t. So it is a minus 1 times b minus 1 times c minus 1. We take negative 1 to left hand side, it will be plus 1 equal to 2024. If we subtract 1 from both sides, it will be a minus 1, b minus 1, c minus 1 equal to 2023. Now, so let me erase this part. Okay, here the product is 2023. We should know prime factorization of 2023. Which is 7 times 17 times 17. And now we know a was what? A was 2x squared. So each term is 2x squared. So it will be 2x squared minus 1. Next one is 2y squared minus 1 and 2z squared minus 1 equal to 7 times 17 times 17. So for one of them, I want to see which of them possible. For example, 2x squared minus 1. Can it be 1? Can it be 7? Let's write number of divisors here. The number of divisors is 7 times 17 squared. And we know it is at least x, y, z. The problem says are positive integers, I think. Yes, positive integers. So each of them is at least 1. At least 2 minus 1, 1. So we should only focus on positive divisors. And the number of positive divisors, you should add the powers plus 1 times each other. Because a divisor can be 7 to the 0, 7 to the 1, 2 cases. And 17 to the 0, 17 to the 1, 17 squared, 3. So we have 6 divisors. We should check all of them 1, 7. Then the next one is 17. The next one is 7 times 17. The next one is 17 squared. 1, 2, 3, 4, 5. The last one is 7 times 17 squared. I've checked all cases. And the problem says what? I find all triples of positive integers. So let's consider these things. So when we consider 1, we will see, okay, 2x squared is 2. So let me write in another places. Let me erase this part. And let me analyze. I want to see which divisors are possible. So if I consider this part, okay, the first one, 2x squared, if you add 1 to both sides is 2. So if you divide by 2, x squared is 1. X is positive, so x is 1. This one is okay. The next one, 2x squared, if you add by 1 is 1 plus 7 is 8. So if you divide by 2, x squared is 4 because x is positive, x is plus minus 2 because x is positive, x is 2. The next one, 2x squared, if you add by 1 is 18. So if you divide by 2, x squared is 9. So x is plus minus 3, so x is 3. Now 7 times 17 is 7 times 7, 49. We have 4. 7 times 1, 7 plus 4, 11. Okay, so 2x squared is 120 if you add by 1. X squared is 60, so this case is not possible. The next one, 2x squared minus 1 is 17 squared. 17 squared is 289. 2x squared if you add by 1 is 290. And if you divide by 2x squared is 145. Also here you could say, okay, it is 17 squared plus 1. 17 squared plus 1 is not perfect square. Is not, because it is twice perfect square. Okay. So we've considered that and it's not possible because 145 is not perfect square. The last one, 2x squared. You add 1. 7 times 17 squared is 2023. You say, okay, it's 2024. If you divide by 2, it's x squared is 1012. Okay, so you should check that is it perfect square or not. It's multiple of 4, so you say 4 times 2 times 4, 8, 21. 5 times 4, 12, 3. 4 is perfect square, 253 is not perfect square, so it's not possible. So the only possible cases are, they can be, let me underline, 1, 7, 17. These 3 cases were possible. The other cases were not possible. So 1, 7, 17. If you want to check, each of these numbers can only be 1, 7, 17. Only these cases. So, because we have two 17 squares, so 2 of them should be 17, and 1 of them should be 7. Okay, these cases. So, the other things are permutation of these things. So let's check for x, y, z. For first one, for example, x 2x minus squared minus 1, we've calculated 18 over 2, 9, 3, 3, and this one 8 over 2, 4, and it will be 2. So the permutations are also 3, 2, 3. The problem is symmetric with respect to x, y, z. 2, 3, 3. Okay, so the whole solution is this part. We have these 3 answers. Let me write another factorization for you. Try to factorize these terms. One of them is as homework number 1. a cubed plus b cubed plus c cubed minus 3abc. Try to factorize this, write it as product of two terms. The other one is a squared b plus ab squared plus a squared c plus ac squared plus b squared c plus bc squared and plus 2abc. Also try to factorize it, try to write as product of three terms as homework number 2. Okay, there are some other factorization it's good to work on. Vieta's formula helped us in this problem. Without that also we could factorize. So two important things you should know: Vieta's formula and Newton's sum. We can solve Stanford hard problems of Stanford Newton's sum with this idea, SMT Stanford Math Tournament. And useful these two formulas, and we have some other formulas that you should memorize in algebra, number theory, and we have around 40-50 important formulas in geometry, also important ideas in combinatorics. For example, when we have lines, circles, some points inside that, outside that, on left side, on right side. In recursive sequence, we have an important question that helps you to solve IMO problem. If you want to know them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Please don't forget to subscribe, turn on the bell, and like the video. Thanks. Take care. Be safe.